Hello my friends, how are you today? I'm Andreas from Motorfanatics and welcome back to our workshop. Last time we cut out a piece of the front support bar here, namely this piece, and today we are gonna indulge in some CAD designing, which is kind of doubling on itself. Cardboard aided design. And after the cardboard stage, we're gonna do something new and do real CAD, computer aided design, and print some brackets with a 3D printer. First of all, like I said last time, we're still gonna need to deburr the edges. Look at that! Shame on me! The other side looks good though. What do you guys say? That's a good one. Almost. Almost. Now the tools for some fine measuring. Some calipers. Let's have a look. Right about here. No. 45, 46, 47, around about 49 millimeters. Let's have a look on the other side. Please be the same. Oh yes, it's around about 49 millimeters. There's a little curvature. With this can see the little curvature down here, which of course we need to work with. I'm gonna show you on this cam once more. We've got a slight curvature, slight bend right here and on the other side, and if you turn it around on this side of course as well. We need to remember this when later on designing the 3D printed part. But first of all, the most important part for CAD, cardboard. Everybody loves working with cardboard. So, do we have any kind of right angle? No, we don't. But that's not bad at all. Just gonna make us some right angles. Does not need to be rocket science. Here we go. Now we know that's a straight. 90 degrees from that. Just scratching it. Switching to my trusty ruler. Oh. That's almost straight, let's be honest. This side is not the most important one. I really need new blades. Oh! So much for rocket science. Where did the rocket go? You know, somewhere between here and Alpha Centauri. Just cut it roughly. Very rough. Fingers out of the way. Applying a little pressure. That looks nice enough. Another one. Here we go. Of course, being the stickler that I am, and It's not even that crooked, is it now? You tell me. Beautiful. That looks promising. Like the professional I am, not. I took my cardboard, marked it with I for inner side and 60mm to remember myself what I did there. And now the other part, that's okay. Yeah. Now it wants to change the angle. We don't want that. Just want to know how far we can put it straight in. Seems round about there. Now let's have a look. Not bad. Almost the same. Nice one. Now on this side, same test. Maybe the sides are different. Nope. To remember, the studs here with the threads are pinned in. That means we need to leave a little pocket down there. Round about there. Does that fit? Maybe let's make it a little bigger. Around about there. Make a nice pocket for that one. It's not that big. Come on. We cannot completely put it in from down below because the other bracket is in the way. That means we're gonna have to push this side in. So we need to make this a slot the whole way down. Okay. We're not interfering with any holes here. They are far lower. Not interfering with any holes, also far lower. Except the one we cut. That means we can go now back to the table and finish our wonderful design. So back at the table, we've got our 60mm. We're gonna add, no, let's say, don't want to make it too tight. I'm gonna change this to 55 and make the other side 55 as well. That's way enough and it's gonna leave us with some nice tolerances.
Hey guys, Andreas here from the cutting room. At this point of the video, you guys should see and hear me explaining how to design basic parts for 3D printing using Autodesk. Unfortunately, the audio in which I explained just that is nowhere usable, and that's why all you are left for now with is a short time lapse of me designing this basic part. If you want to see a more detailed explanation in the future, write it down in the comments below and we will make sure to make it one of our next videos. But for now, enjoy the combined time lapse of designing the part and 3D printing it too. See you soon.
Now we're back in the workshop, guys. The 3D print is finished. You maybe have noticed the, well, rudimentary time lapse, let's call it that, instead of Unfortunately, the parts did not come out perfect. If you take a closer look, they are warped, as in not straight. They lifted from the building platform, unfortunately, and have a rough surface texture. If you guys, by any chance, are 3D printer manufacturers, send me one. A better one than my Tronxy. I can make good use of it. Promised. As you guys may just have seen, the parts don't fit. Well, they almost do fit. The big pro of this kind of filament is you can sand it. PLA, for example, if you sand it, it gets mushy, it gets soft, and well, you can't sand it at all, really. Well, you could, if you go slow, sand it by hand and give it time to stay cool, but I don't want that. So that's why we're gonna sand it with the orbital sander. Would you look at that? Now to the other side, let's have a look at the fitment there. Still not perfect, but the little notch we carved out fits under the bottom of the stud, and it almost goes in all the way. Almost. There's a little dent in the metal here, but a little bit of lovely force will do wonders. That will work. Nice one. Just for testing purposes. That looks almost stock. No. With all the holes tapped, we can now test if they really fit, and they do. One thing I did not measure before was the diameter of those little shims. Now is the moment to notice if they fit next to each other. And they do, but so close. Of course, this was on purpose. I always knew they would fit. Of course, I did. Seeing that all the screws just fit, that all the shims fit, makes me even more cry about this shitty 3D print. But it works. So much for that, guys. That worked out, I'd say, reasonably well. We put them in a high rack for now, because next episode, unfortunately, we finally will sand the engine bay. Can't avoid it any longer. So if you like this episode, don't forget to give it a thumbs up. If you really like our videos, consider subscribing, and see you next time.